Okay, dear students, here the classification of algorithm for the previous slide we have discussed. So the previous slides we have discussed the classification algorithm. One is the elimination method and another is design approach. Here is the design method. So design method, there are a number of algorithms that go through that each and every one. Very simple. One is a brute force, recursive, backtracking, searching, sorting, hashing, divide and conquer, greedy, dynamic programming, randomized algorithm, decrease and conquer, branch and plot. Here we will look at each and every one in the next one. First one is a brute force. Brute force approach can be also called as exhaustive search. An algorithm tries a large number of patterns to solve a problem. So brute force, another way is called as straightforward. Here in brute force, never use any method. So other name of the brute force is a just do it. Just do it. So here there is no method is there. Here they don't bother about the time complexity or space complexity. They just you have to execute the process. Okay. So this is called the brute force. Example: sequential search. There is no method is there. Sequential search means here there are n number of data is there. You are searching one by one. Whether the data is present in the given data, suppose whether the data is not present in the given data. So don't bother, just searching one by one and one. Suppose this data is in the nth element means it is the result. Okay, so this is called as a brute force. Next, recursive. A recursive algorithm is based on recursion. You already have to know what is called as a recursion. So a function call itself again and again to perform a base condition, to satisfy the base condition. So this is called as a recursive. So here there is some examples there: tower of an eye, in order, pre-order, post order, as well as DFS, does for search of graph. So this is a recursive. Go through that. What? Next, backtracking algorithm. What is called the backtracking algorithm? The backtracking algorithm basically build the solution by searching among all possible solutions. Using this algorithm, we keep on building the solution following some criteria. Listen, this is very important. Whenever a solution fails, we trace back to the failure point and build on the next solution and continue this process till we find the solution of all possible solutions are looked at. So students are very familiar with the example. One of the example each and everyone familiar with the chessboard, also the maze games. All are very familiar. So maze game means we are going on path. If the here after that there is no path, it's there. You come back. You are searching for the other path. Once again, you have to go to the path. Here there is no another path. Means you are coming back. You are searching. Likewise, you have to. This is called backtracking. Afterwards, you are searching on path. You have to go to the path. So here, just you are forwarding. There is no path. That means you have come back. You choose another path. Here you have to go to. Here also there is no path. This means once again come back. This is called as a backtracking. Okay. So first one is a brute force, second is recursive, and it's a backtracking engineer. Next is a searching algorithm. Searching algorithm are the ones that are used for searching element or group of element from a particular data structure. Same thing, sequential search, binary search. Suppose you are searching. Okay, so sequential searching is me have to search one by one. Binary searching, choose the midpoint. Based on the midpoint, you have to search either left hand side or right hand side. So here you are using a techniques. But in brute force, there is no technique here used. Just do it. Next, sorting algorithm. What is sorting algorithm? Sorting is arranging a group of data in a particular manner according to the requirement. Based on the requirement, you have to sort it. The number of different data is there, sorting it, maybe ascending order or a descending order. Okay, we are well familiar, just yet go through. Hashing. Hashing algorithm works similar to a searching algorithm, but they contain an index with a key. Here we are using index as well as key. Based on this, hashing operations are take place. Next, divide and conquer. Everyone are familiar with the divide and conquer. This algorithm breaks the problem into sub-problem, solve a single sub-problem, and merge the solution together to get the final solution. It consists of the following three steps: that divide, solve, and combine. So divide and conquer means there n data is there. So you have to split the data. You have to split the data. Is you have to make it easy to sorting. So divide the data. Next you have to solve the data. Once again you have to combine it. So this is the divide and conquer algorithm. Next, greedy algorithm. This also each and everyone very familiar. Go to the definition. In this type of algorithm, the solution is built part by part. The solution of the next part is built based on the immediate benefit of the next part. The one solution giving the most benefit will be chosen as a solution for the next step, where we select the next best solution to solve the problem. Students, we are already known about greedy algorithm, that is a minimum spanning tree. Best example is minimum spanning tree. In the minimum spanning tree, we are using two algorithms, resistor algorithm as well as Kurzweil's algorithm. You have to find the minimum cost. So this is the best example. Next one is dynamic. So dynamic is the algorithm uses the concept of using the already found solution to avoid repeated calculation of the same part of the problem. It divides the problem into smaller overlapping sub-problems and solve them. This also students are well known to find the shortest path. To find the shortest path. So overlapping means in the routing table you have to overlapping the values. If minimum value is obtained means you have to overlap. If maximum value obtained means you are not able to overlap, not to overlap. So what's the concept of dynamic programming? To find the shortest path. So you have to shortest value and you have to update that. So it's just algorithm is to you to find the shortest path. So this is a dynamic programming. Next one is the randomized algorithm. What is called randomized algorithm? Go to that. In the randomized algorithm, we use a random number, so it gives immediate benefit. The random number helps to indicate the expected outcome. So there are we are using random numbers and we have to find the expected outcomes. Next, decrease and conquer. What is called as decrease and conquer? Go to that. Decrease and conquer is a technique used to solve problems by reducing the size of the input data at each step of the solution process. Consider topological sort. What's the topological sort? There are input, there's a, yeah, in edges as well out degree as well in degree is there. So based on the out degree, we have to reducing the inputs and you have to find the solution. Next, fake coin. Consider on n number of coins there, n equal to 10 number of coins there. Just you have to find the one of the coins a fake coin. How will you find the fake coin? In data, you have to divide it n by 2. Once again, n by 2, n by 2. Then you have to find. Then you have to using the physical balance. You have to find it. Suppose you find the alien means you have to. This is what is a decrease and convert. You have to reduce the size of the input. You have to reduce the size of the input because that huge input is there. We are not able to identify. So you have to reduce the size. So based on the reducing size, you are using to calculator. So this is called as a decrease and conquer. What's the next one? Branch and bound. Whatever branch and bound is another computational optimization problem. To systematically search for the best solution, it works by dividing the problems into smaller subproblems or branches, eliminating certain branches based on bounds of this optimal solution. This process continues until the best solution is found or all branches have been explored. Traveling salesman problem example, computational optimization. So here is the same concept. You are dividing the problem. You have to find the lower bound and the upper bound. Based on the lower bound and upper bound, you have to find the optimal solution. This is called as a branch and bound. Later we will discuss deeply using the problems. So classification of algorithm. So how will you analyze the algorithm? One of the analysis of algorithm is classification of algorithm. How will you classify it? One is implementation method, design approach, as well as design methods. So here you are using some design techniques. I think well known, we have discussed.